Lesson 5-4, Solving Compound Inequalities with the connecting word OR, Day 2. Our essential question is, what are the three types of graphs that may represent a compound OR inequality? Our first vocab word is compound inequality. A compound inequality is like a compound word. A compound word is a word that is comprised of two or more smaller words that could stand on their own. So a compound inequality means two or more inequalities. And they're connected by the word and or. Okay, so the connecting word or means something completely different than the connecting word and. So the connecting word or you can think of as a union of two things. So to be in the union of our circles here, our Venn diagram, here's one of our circles, here's the other. To be a point in the union means that you could be anywhere. You could be in the blue, the yellow, or the green. Union means to unite together, to combine. So you could think about like a union, like when families, like if two families combined together, then they would be united as a whole. So we're not talking about just where they overlap, we're talking about everyone just being put together, joined together like a family. So, to get a discount at Perkins, a person must be an armed services veteran or at least 60 years of age. Shade the union of these two sets. Well, the armed services veterans are over here. So this would be like my dad. He would be in this area over here because he is a veteran. And then over here on this other side, this would be my mom, because my mom, she is over 60 years old. She's over 60 years old. The piece in the middle though, those are the people. So I'm going to say like, this would be where my dad would be because he is an armed services veteran, and he's over 60. He's greater than or equal to 60. My mom, though, would be over here because she meets the age requirement, but she's not a veteran. And then I've got some cousins that would be over here. My cousins are veterans, but they are certainly not 6 years old yet. So my cousins, because they are less than 60, but they're veterans. My dad is both a veteran and over 60, and then my mom, who's just over 60. So the thing is with the word or, the union with the word or means that all of these people are getting the discount at Perkins. All of them. So you only have to meet one requirement or the other. So one requirement or the other, or maybe you do meet both requirements and you can still get the discount at Perkins. So it's very different from looking at an intersection, where an intersection is only people who are in that intersecting piece, that green piece on the Venn diagram here. The intersection, you had to meet both requirements, so it was a really small group, like a narrow group. This one is saying if you meet one requirement or the other or both, all of you get the discount. So a union is like uniting together so that it's not being so selective. It's not being so selective as the intersection. So intersection, more selective just where they overlap. Union, uniting together two groups, including all of them. You only have to be one of the things for it to matter. Okay, so now we're going to solve, and we're going to unite together our rays here. So union of the rays. So we have two inequalities to solve and graph, and then we're going to put them together. So I'm going to just solve both of these at the same time because these are pretty basic inequalities for us now. So the first thing I did was added or subtracted, and then the second thing on both I'm doing is dividing. So x is less than or equal to 1, or x is greater than or equal to 4. So 1 to 4, those are the four numbers that I need on my number lines. We're going to look at the rays separately, and then we are going to put them together. We are going to unite them. So less than or equal to 1, it's a closed circle going to the left where the numbers get smaller. And then greater than or equal to 4 is a closed circle, but going to the right where the numbers get larger. So what happens if we unite together? We unite together these graphs. So if I put these two together, they don't overlap each other at all. Not at all. But you don't have to have an overlap for a union. So I'm just going to clone this because for my solution, I'm going to have both of the rays in my solution. Because think about that Perkins discount. You just have to meet one requirement or the other one to get the discount. So this is saying, tell me a number that is less than or equal to 1 or greater than or equal to 4. So they both count. So our inequality is just that. X is less than or equal to 1 or x is greater than or equal to 4. So we solved both of the initial inequalities and we keep them. We keep both of them. They're two separate rays. Two separate rays. So we have one inequality for each ray and we connect them with the word or. Okay, the next one says type 2 and it says one ray. So we can expect something different to happen on this solution because the last one had two rays. So solving both of these inequalities, the first one is just one step. The second one is 2 steps. So x is less than or equal to -2. That one is done. -3x is greater than or equal to 3. So I need to divide by -3, which means flip my symbol because I'm dividing by a negative. 3 divided by -3 is -1. So these number lines, all I need is -2 and -1. I guess I'll put a 0 on for my third number. Okay, so the first one, less than or equal to -2. Closed circle, going to the left for less than. The second one, less than or equal to -1. So closed circle again, going to the left again. So what happens if we unite these two rays together? If we put them together, one of them runs right over the top of the other. Now, we are looking for a union. So because this is a union, it's not where they overlap each other. It's anything that's on either ray. So this one has to start over here at the -1 and go to the left. So it's one ray, and to name that ray, it would be x is less than or equal to -1. So I don't need the or, and I don't need the other ray. I don't need the one that said x is less than or equal to -2 because -1 ran right over the top of it. So when I unite them together, I don't need that one. I don't need that one at all. Okay, type 3 is called all real numbers, and this one's ready to graph right away. So I need the numbers 1 through 5. Okay, and my first one is x is greater than 1. So it's an open circle going to the right. My second one, x is less than or equal to 5. It's a closed circle going to the left. So what happens if I unite these two together? You take a look at this one. When I've united them together, they cover the entire number line. Every single number is included on one ray or the other. So that means that for my solution number line, I need the entire number line like this, the whole thing, because this union covers every number. So that's called all real numbers. All real numbers. You can write the symbol for all real numbers, or you could just write it out. All real numbers. Every number on the number line would meet this compound inequality. Either be greater than 1 or less than or equal to 5. Every number is included. Okay, now we have just a couple of graphs to make sure that you can write an inequality for the graph. So these are just each of these is just going to have 2 rays on it. So you name them separately. So my first ray has a closed circle, and it is going to the left. So that means x is less than or equal to -1. Then I need my or connecting word for the 2 rays. The second ray, x is greater than 2. And that's it. So that's the inequality that would represent that graph. One more like that. The ray that's going to the left would be x is less than, not less than or equal to though, because it's an open circle. So x is less than -3. Or the ray on the right is a closed circle, so x is greater than or equal to 0. So open circle to the left, so that's just less than on the -3. Closed circle to the right, greater than or equal to 0. You should be able to write a summary now. Make sure that you answer the essential question using complete sentences.